Okay, thank you very much. Yes. Yeah, I will start. To keep you awake a bit after lunch, we think we do it together. Maybe that gets a bit more energy in the room because this is the most difficult time, we know. I'm going to talk about corrosion. My history is 37 years in coatings, coming from Delft University, but before Herman and Arjen Mol came there, so there was no corrosion there. I did polymer chemistry, and I kept on doing all my things in coatings technology. First 9 years marketing, 9 years research, then 13 years of the dark side marketing, of which first 3 years in Moscow. But since 10 years, I'm responsible, as you can see, for the scientific academic partnerships. So for all the collaborations, academic, we have running. And it's rather a lot in reality. Good, to go quicker. First, the comms talk, so the corporate discussions. We are great, we are good, we are the best. I think you've seen them before, probably. We have 3,000 scientists worldwide. That's quite a lot, to be honest, still. We are, therefore, the biggest European coatings research organization. That's quite big. We have about 400 people in the UK, about 400 people in the Netherlands, and that's really quite a big group. And we use the people, planet, paint purpose to make clear what we want. People, of course, the planet, yes, of course, we want to save the planet, but still, we need to make paint. Paint is what we do. So we have the focus areas around avoiding climate change, be careful, and increasing circularity. It's always a bit, I found it a bit difficult if you write it like that. And of course, don't forget, because that's number 3, health and well-being. Too much you see people only talking about environment and forgetting that people's health is not always the same. We have clear indicators on how we want to do it. 50% carbon emission reduction in 2030. That will come back in my story, so therefore I can say more about it. Well, it's something about circular waste, revenues from sustainable solutions, training people. Yes. How can you see we do it? It's not only that corporate talk. If you see where AkzoNobel is, and one of the most interesting ones is always the EcoVadis, where we are platinum. You see everybody using EcoVadis. Most people are gold and silver. We are so far still platinum. We are a bit in the danger zone globally because in UK we had a leakage, as you may have seen in the press, and leakages, incidents are always counted. So you have the highest score ever this year, but it's a bit discussing how bad that one guy leaking paint into a river is for your score, and it has an influence potentially. But interesting for England, people at least they understand is that we have the Terra Carta like nobody else. We received it during the Glasgow conference from then Prince Charles. So our CEO was so happy he could get it. Good for him. Let's do the real things. Where is it coming from, our carbon footprint? We had a big talk last week in the European Coating Show. You can see that 46% of the total carbon footprint is happening with our raw materials before it enters our gate. That is titanium dioxide, making it white, is high temperature baking. That's epoxies, polyesters, long time baking, cooking them before they are made. A lot of this carbon footprint is purely in the production process, where you need a lot of energy, way too much often. Yes, it's only 2% we do. It's not because I want to greenwash myself, but what we do is we get raw materials, we blend them cleverly, put them in a can, and send them out. Well, that's not the biggest carbon footprint. We are so happy that we are almost 100% carbon neutral already in our factories, but it's only helping 2%. The big part is customers and VOC. Customers is big, 30%. It has to do with high baking, powders, coil, but also automotive baking. And it has to do with all the overspray and spray loss we have. So the application loss, that's quite big. 11% is the VOC, so trying to reducing VOC further always helps. And only 11% is end of life. That's often forgotten. It's major important. It's one of the many steps, but it's not enough. Because even if we take all these 11% bio-based, we will win 7-8%, because normally bio-based products need more energy there. That's the big problem they have. So it's not that easy to go to 50%. It's not just make your world bio-based and you're there. And it's even a bit worse. I heard great stories about bio-based additives. When I was last week, I did a presentation, and before me somebody told about a great additive that was now bio-based. 0.1% in a paint you needed. So 0.1% bio-based, you can hardly see it if I change it. And there was quite a difference in your production process. So it is not just one-on-one replacement. There's a lot to happen. The good part is, I'm 37 years in this company. Peter still has 20 years to go. He won't be finished when he's ready. There is so much to do to make paint sustainable in the coming years. There's an interesting story in there. Everybody hopefully knows the Ellen MacArthur Foundation. Very nice graph showing from mining and manufacturing all the way down in your value chain to landfill if you're really unhappy. That's not where you want to end. On one end, it's the technical materials loop, reuse, recycle, re-maintenance, all the things you can do. And on the other side, it's the biological loop, which is, of course, normally much more difficult to make it really a loop. You have a lot of loops when we, in fact, get all these things outside in. When I try to make a graph like that for paint, it looks really simple suddenly and not so nice. Sorry, I'm not such a good drawer as the Ellen MacArthur Foundation. But it's still the same loop from top to bottom, where we are able to make the mining and manufacturing raw materials up to a painted surface. I think, and I have to be honest, that there is also a landfill over here still. But it has to be avoided, so let's not make it the target and put it in the schedule. On the right side, we have the technical materials loop. How can we reuse materials that we have, old paint, but also all kind of other stuff. Nicest recycle from other sources is always that we use the tires from airplanes in the paint we use on what is the vliegtuigschip and the big war carriers. That's what they're called, yeah. To make the planes when they land there have the same rubber to land. Well, sometimes you can use the same stuff. Normally you can't, but you have to do your best. So we reduce what we can in the line. I say reuse where we can technically, and renew where we can biologically. And then we see where are we. If you see where we are reasonably good in reducing. Solvent-borne to waterborne, we made big steps compared to 50 years ago, compared to 20 years ago. Still things to go. We still have steps to make in low bake, but we're getting there. Lower VOCs we have, lower substances of very high concern, that's that other thing coming back, the people factor. But we need to go to longer service life, at the end no carbon emission. We have something in the reuse, being paint waste recycling, recycled packaging, but we need to do more recycled raw materials, and we need to get really triggered release, biodegradable coating, get it all done so that we are absolutely able to reuse our paints much more cleverer. And on the bio-based route, we are just happy to have L-kits historically, and like so many often things, not because they are so great, but just because they were so cheap in the beginning and they were available. And now we make them much better because solvent-borne L-kits for outside are still very durable, to be very honest. But we go to low amounts of bio-based content by binders, and we do that often via mass balance. That is this difficult trick, like your green energy, they compare it. But where we want to go is more bio-based, and even for C14 bio-based. And at the end of the day, and preferably sooner than later, full bio-based and bio-based colors. For bio-based, we have seen a lot of developments happening the last years. More suppliers are active. You see more C14 coming, but also mass balance, because it's the way to make a step. And at the end of the day, 100% mass balance is the same as 100% C14, in the way that it's calculated. So we're making steps there, also in Asia. The trick still will be the economy of scale. How can we get the prices down? How can we get hard bio-based monomers? You see that now happening, that there is quite some developments also in Horizon. And how can we get the performance differences really as low as possible, unless it's a total drop-in, but by the time it's a total drop-in in the chemical process you have to do before you are there, you use a lot of energy as well. We do that in a number of academic collaborations. I just mentioned a few there, but there is quite some more already. An example is this one, where we tried, it's quite new as such, via to get from furfural, which you can get quite simple from cellulose, to make via light initiation and a butanolide. And via the butanolides, you can do a direct reaction. You can also get them further in the reaction that is now all published to get acrylic acid out of it. The trick is, of course, that you use a light initiator, really photochemistry. Photochemistry is still, just like electrochemistry, a reasonable, undeveloped opportunity for using electricity directly in your process, instead of heating it with a lot of oil and gas. And we see that there is still a lot of possible there. We're looking how we can upscale it together with Nottingham effect. What do we do? A lot of transitions. Everybody's talking about the energy transition. Yeah, we know that. You often see only the materials transition next to it. I split it here into a feedstock transition because I think they are different versus the materials transition. The energy transition is how we make and store the energy. Feedstock transition is the bio-based and the circular. There's a lot of attention. And the materials transition is how we use the materials, how we can use them more clever, how we can get the functionalities better so they do more. Is not really taken enough into consequence, I think. When I started 37 years ago, I received a book. This is about coatings. You read coatings, paint and coatings are primarily used for protection and aesthetics. If you now try to sell a product that is only protection and aesthetics, you hardly sell anything in deco, but also in a lot of the industrial, they're hardly interested. The functionality, I gave a few here, are so major. If you know the coating on your telephone, that's all anti-fingerprint. That's what it's all about. And you won't see it because it still looks like a horrible. Try it with a normal glass plate and you will see how it will look like when it's not an anti-fingerprint coating. That's ours, to be honest. Anti-fouling is mentioned there. In fact, there are a lot of functional coatings. So many that I have here, 36. And it is not a full list. Most of that you can think of have an overlap with the others. There's a lot of overlap, that's what you see always. So I have the color group, I have a group of functional surfaces where it's really the surface doing it. There's a lot happening with radiation control. That's especially with the new batteries and all the things happening there and the thermal heating. There's a number of substrate control. And I'm not mentioning corrosion because that was the normal protection we said. And all kind of other bulk effects. We are good in some, the green ones. We are reasonable in the number, but we can still make significant steps. That's the amber ones. And we are still quite poor in the red ones. Odor removal, because there's too many smells you can make, and it's too difficult to get them all catalyzed all out of it. Thermoelectric, because it's really tough to get electricity controlled. And photovoltaic, we have a jar on the table. If somebody tells you again that there is a photovoltaic paint that you can just roll on the wall and get electricity out, you have to put money in, because it will never work, I promise you. Not with any of the perovskite, not with any of the classical products. That is not how it is. It's a great opportunity, photovoltaic, panels, foils, whatever. But don't talk me about the photovoltaic paint that you can just roll on any wall. Enough reasons why not. This is possible. This is much more interesting, maybe even. Just a solar panel, whether it's green or, in fact, a heat panel, whether it's green or when it's grayish. And it collects so much more energy just by collecting the near infrared. In fact, in the visible light, it does nothing. You can do this with black, but that looks horrible. This one collects even more than normal black, even in the infrared. It's a special pigment. And therefore, that panel gets really hot, because these are panels that's all collected. You can see a bit how it works over here. And with a panel like that, you can heat that house the whole year through. You don't need any electrical heating additional to it. You need a bit of electrical power, but the roof is still empty, so you can still put your solar panels on the roof. This house needs no more electrical heating at all, or like gas heating at all. The point is that regulating it is not easy. Software is a mess to be made, and therefore it's still expensive. But it is a future that is absolutely there, especially when you do it with bigger houses. This is typical something that you can do for smaller houses. Good, another thing is self-healing. My voice is still making it. We know it exists. with a bit of infrared. But what you want, of course, is room temperature healing. How can you do that without visible scars at room temperature and still have good hail, get the perfect protection, including the corrosion protection? It all has to do with energy harvesting. We've seen a few things yesterday as well. Wind turbines, water turbines, it's always the pressure and the enormous speeds there that need a lot of extra protection. Solar photovoltaic panels use a lot of paint effect to protect them. Thermal panels. Micro energy harvesting is just coming up, and it will be much bigger in the coming period. There's a lot happening. All in all, sustainability, as we all discuss it, is not possible without functional coatings. So there is so much more possible to use the right functional coatings, and this is still, for a big part, an uninvestigated area. One of the things we should do is to indeed take care of better corrosion, and my friend will tell how that works.
Thank you, Andre. I'll do it without my...
You do? I put it off, otherwise I'm...
Okay,
my name's
Claudio di Lullo. I'm Technology Research Manager for the Corrosion Expertise Centre Expertise Group now in AkzoNobel. And I'm going to talk a little bit about the corrosion side and what we do. I've been with AkzoNobel, or in the AkzoNobel family, this is my 36th year, so not quite as many as Andre. And I originally was employed, or still am employed, by International Paint Limited, which is important because I'm going to talk a little bit about academia and our relationship with Manchester as well later on. Okay, you've seen this slide before. I'm going to talk a little bit about, from a corrosion perspective, of reducing VOC. Yeah? So that's one way of reducing solvent emission, reducing VOC. That's one way we can address some of the sustainability challenge. And within AkzoNobel, we have the Waterway program. It's been around for quite some time, and it's transitioned from solvent-borne to waterborne, particularly in the decorative coatings business. And we have this product, which we'll talk about a little bit later, called Hammerite Ultima. And this is a waterborne corrosion protection product. So, that's where we are now. Going forwards, we've got this journey, 50% reduction in carbon footprint, the value chain. So we're looking at development of paints and coatings that don't need solvents. And also, some applications do need solvents. So how can we recover the solvent, reuse the solvent, at least not release it to the environment? These are all things we can do. So I mentioned Hammerite Ultima. It's a waterborne version of the well-known Hammerite brand. Direct to metal, direct and to rust. 12 years protection. It coats any metals, quick drying, no primer necessary. Great product. We're protecting corrosion with a water-based material. It's fantastic. But it's only the start. Where do we go next with water-based? Well, basically, we have to look at some of the harsher environments we service. Our marine environment, our aerospace environment. These have much more demanding needs for our coatings. So that's where we're going with our water-based. Next, the substance that you might all have heard of, chromates. Removing a material of high concern, or substance of very high concern, chromates in aerospace. Chromate's wonderful things. Best corrosion protector. Used as a pre-treatment. Used as an active leaching pigment. But it's not nice. It's toxic, it's carcinogenic, a substance of very high concern. The EU, and part of the REACH program, is banning chromates. And at the current moment in time, the strontium chromate, the sunset date, January 2026, and other chromates pre-treatments, January 24. We knew about this a long time ago. So we started working on replacing chromates. And basically, we looked at a lot of things, a lot of different mechanisms, a lot of different inhibitors, until we hit lithium. And lithium proved to be our route towards chromate-free coatings. Now what we have here is sort of rough timeline, some early papers involved around lithium, and then Peter, who's in the audience here, along with Scott Hayes, we put our patent application in 2010. And this is taking an idea, the ideas from the literature, and turning it into an invention. And that's what we have to do, to innovate, to create something that we can sell and make commercial. That's 2010. We're now 2023. We've got some products out. We haven't got a full range. Developing products takes time. And this ongoing development, it takes time and it's very intensive. And a lot of it is because of the time taken to do the testing. So, what do we do? What do we need to find new solutions? Well, there's a whole host of things we need to do. But, connecting science with product development, that's our strapline in this area. And there's a whole host of different things. Yes, we work with suppliers for new materials, be it corrosion inhibitors or be it other materials. We develop analytical techniques, in-depth knowledge of corrosion inhibiting mechanisms. We work with the customers. But in the middle of it all is our collaborations with institutes and universities. And they supply us this information on the in-depth knowledge and some of the new analytical techniques. And we're in Manchester. We're in Manchester today to celebrate 65 years of corrosion research. And like I said, I still am employed by International Paint Limited. We've got a long relationship with the University of Manchester. It started in the mid-80s when International Paint made David Scantlebury the lecturer for corrosion control, the reader for corrosion control.
International Paint PLC lecturer in corrosion protection.
There we go. International Paint PLC lecturer in corrosion protection. And we still maintain that relationship today. With, Stuart now being AkzoNobel's professor of corrosion control, which I think I've got right this time. So, there's a lot of things have gone on. You've heard work today that Suzanne's talked about from the Corrosion Protection Partnership that Stuart and Simon, who's in the audience, helped involve set up through to Suscord. And you've heard work from Vincenzo about Suscord. I'm going to talk a little bit about Suscord. What does Suscord mean? It comes from Sustainable Coatings by Rational Design. And it's an EPSRC Prosperity Partnership with AkzoNobel as the business lead, the University of Manchester as the academic lead, but also the University of Sheffield, the University of Liverpool, and indeed, as I'm speaking, the University of Exeter are formally joining this partnership too. So those brackets can come off probably next time we speak. So, and again, this was set up by Stuart and Simon, who's in the audience. I've just inherited it after Simon retired. What is the vision? Well, we aim to connect, I have to read this because I never remember it, the physico-chemical properties of protective organic coatings with their service performance in order to enable the development of process and formulation models such that novel, environmentally sustaining material solutions can be rapidly developed by the application of digital predictive design. And the digital predictive design, say, you've seen some of that already through Vincenzo's talk. We've got 4 work packages. And we've got some of the more traditional coatings work packages along the outside, polymers and interfaces, coatings and substrates. We've got a work package on modelling and simulation. But in the middle, we've linked them all together through the predictive design and testing. So what we're doing is taking our knowledge, our historic data, in conjunction with Suscord. The idea is to design a toolkit for rational design, so guidelines to how to formulate our coatings going forwards. So that's Suscord in a nutshell. Where does it fit with what we want to do? Well, our business lead, as Andre talked about, sustainability, we want new differentiated sustainable products. To make money, you have to have something that's ahead of the game. With the knowledge and capabilities that exist within universities and AkzoNobel, through the Suscord program and beyond, because there's VIPCoat that Herman talked about, PredictCore, there's all sorts of other opportunities we're using. We're looking to get that edge, the impacts, the insights that gives us the ability to accelerate new product development. And you saw from that listed timeline how long it takes to develop products. So anything we can do to reduce that gives us an advantage. So, what does it bring to us? Well, it brings us new hypotheses with coating phenomena, new test methodologies, predictive testing, and predictive formulating. This is another aspect of the machine learning program, where we're using machine learning to predict new formula, new formulations from the data that we have. And all of this is to accelerate our product development. Thank you for listening.
Thank you very much. It's open for questions.
To be sure you can hear me, because my voice is a bit... it was a good party yesterday, great, thank you. Scraping off paint from the wall and reusing it would be great, but it's almost impossible. What we have seen what happened is that dried paint coming from a substrate, for metal they do it sometimes, they scrape it off before they use it, because the fillers in your paint are in fact heavy pollution for reusing your metal. So therefore they have this paint. The only thing you can do with it is more or less to powderize it, to get the titanium dioxide and really the fillers and the pigments out. Anything else is in practice almost impossible since it is cross-linked. It's not the same monomers you apply when you use it. It's a total different system after you're done. And like too many things at the moment, it's the same with a lot of other of the organic materials. Pyrolysis is still the way to get carbon done, and it seems to be green. I'm not sure there. Yeah, it's a good question. We thought about it.
Thank you. Any further question?
We were so clear.
Actually, when you put up the graphic at the beginning, there was, I think, 44 or 60% of the carbon footprint comes from the suppliers. So how do you? I know it's easy to kind of like put statistics out there. How do you deal with that? Do you somehow encourage them or to reduce the carbon footprint, and how do you monitor that? Because it's easy to say something.
No, we are the ones, normally I say that, I didn't say that this time. Normally I say also, we only do the 2%, but we are responsible to choose this 46%. So what we are now doing, and we are now incorporating that in our systems, in our programs, that in fact, apart from the cost price, you can also see the carbon footprint per recipe you make. Because you can make a wall paint on a lot of methods, and there's a lot of ways to make a white wall paint, more or less. And then the carbon footprint is now calculated as well. It would be useful, I didn't have my conclusion sheet on it. My conclusion sheet also mentioned that it would be great when there are more regulations for that. Yeah. In fact, carbon costing would change the world enormously in that case, in that aspect. Yeah. And why not? If that's honest against all competition and to us, it would be good. So yes, we take care. It's not that we take our binders from France because they use green energy, nuclear energy, versus from Germany where they use gas energy. But we are at the moment using more overall numbers for all of the binders. So for VAE is a different one than a styrene acrylic. But we are now trying to see whether we should go a step deeper indeed to make the process per supplier. Because the VAE from Germany compared to the VAE coming from India, that has an extra carbon footprint. That's now not in the product if you're not careful. So we have to add that as well. It's only changing by the time. In fact, this is a new graph that's just existing since 2 weeks, because before we had 12% VOC and 12% end of life. And we now see that that is reduced just to the things we know about what already changed and happened. The total carbon footprint already decreased a lot. It's not on this. That 50%, we made about 20% reduction already, just because suppliers are doing much more clever things, and also the customers, they don't bake only with gas, but also with solar energy and wind energy. So a lot happens outside our control as well. But it's good to know what we do, so we can make the choices.
Also that you take care of that, that you keep an eye. I think it's very important.
Yeah.
Okay. Any further question?
You mentioned about bio-based raw materials. How far down the road are we utilising those?
There's a lot to say, and I don't know exactly where to go myself even. if all the carbon we use would be changed from fossil to bio-based, we need about 4 times the food we have totally today, because there is not enough carbon. So we are not that far, luckily, because we still have food. It's even worse because we're not using palm oil anymore, so we're using a lot of soya oil, but soya oil needs 10 times the amount of surface to grow. So we are cutting even more trees because we don't use palm oil. Yeah, clever. So yes, we're doing what we can. You see it coming up, but it's much more interesting to do it like the Fur for All stuff. It's cellulose. So to really do it from biomass waste side streams officially, and not from food derived. You see a lot of sugar derived things still happening. And is that the same level of biomass as cellulose derived? And I don't like it when it's food derived. But so yeah, it's a long discussion every time, and it's not easy. If it was easy, everybody would have done it, and they don't need to pay me.
Okay, thank you very much.
Thank you.
Okay, next one.